We've completed a technical briefing on the events this morning. The International Monitoring System did exactly what it was supposed to do this morning. Signals were detected on numerous seismic stations, and these signals were immediately made available to all of our member states. Automatic processing was performed on those signals in accordance with our procedures, and the results of that automatic processing were made available to our member states as they became available on the timelines that our procedures prescribe. The first automatic processing results became available at about 2:30 UTC time this morning. These automatic results indicated an event occurred an hour prior at 1:30 UTC time in the vicinity of the North Korean nuclear test, the declared North Korean nuclear test site. This automatic processing made use of 20 signals from 27 different stations of the International Monitoring System, and they showed results that were very consistent with the 2013 declared nuclear test that occurred. The location was very similar. The characteristic of the waveforms were very similar. Automatic processing continues, and additional results were made available at 2 and 6 hours after real time. We're now at a stage where human review is underway of all of these signals, and these results will be available typically about 48 hours after real time. What I can say is that a large number of stations detected this event. The automatic processing used, as I said, 27 stations in its initial analysis at the 1 hour mark, and data from 36 stations at the 3 hour mark. Humans will use data from nearly all the stations of the International Monitoring System. The International Monitoring System is very robust. It is operating at a very high level of readiness. It is fully capable of monitoring the entire planet and providing the data necessary for member states to determine whether events contrary to the treaty take place. And that's exactly what it did today. What will happen over the course of the next few days? If there are any radionuclide releases from this event, those will have to escape from the supposed test location, be transported through the atmosphere. If any of those pass over our radionuclide stations, they will be sampled. There's a sampling time, a waiting period, then a counting time, and finally that data will also be reported both here to the International Data Center as well as made available to all of our member states in real time. Analysis of those results will then be conducted by humans, and those analysis results will also be made available to our member states. So it's too early to make any statements about whether any radionuclide has been detected from this event. Recall that in 2009, no radionuclides were detected. In 2013, radionuclides were detected almost 55 days after the event. So with that, that's the synopsis of the technical information. Oh, I guess the size of this event is essentially the same as the size of the 2013 event. In 2013, we reported a seismic magnitude of 4.9. This time we are also, our initial results indicate a seismic magnitude of 4.9, a seismic body wave magnitude of 4.9. This is an initial analysis. With further human review and refinement, this may change slightly. So with that, I'm open for some questions.
Yeah. Can we start with Francois, please, from Reuters?
You were saying that the characteristic of the waveforms was very similar to the last test in 2013. Does that suggest that it's of the same nature as it's not hydrogen bomb?
I will simply say the characteristics of the signals we have observed this time, or that have been observed this time, are similar in that they have the same frequency characteristics, the same relative ratios of. A seismic signal has many parts, and we compare the different parts of that seismic signal, its duration, the magnitude of different components of the signal. That tends to give indication of whether it's an explosive an explosive nature event, or a slip, or like a fault slip type of event. So what I will say at this point is it's very consistent with what we saw, or what the world saw in 2013, which was a declared nuclear test and largely deemed to be a nuclear test. To go further into detail to try to ascertain some very particular nature, such as the particular nature of whether this indicates nuclear versus non-nuclear or type of nuclear, is not appropriate at this stage. I mean, the seismic data alone would not provide that sort of insight.
Okay, so essentially, if it were an H bomb, it would basically look the same. It would be within them.
From a seismic perspective, I don't foresee that as being something that would be ascertainable from seismic data alone. Let me further stress that that's something that member states would be involved in, not the CTBTO. The CTBTO provides high quality, reliable, authentic data so that member states can then make determinations about whether a violation of the treaty took place. Our job is not to declare an event nuclear versus non-nuclear. Member states have that prerogative and will do their own analysis using data we supply and using any other data that they may have of their own, from their own sources.
Basically, already stated that you cannot say at the moment whether it was a nuclear test for sure or not. I would just be very glad if you could say this into
Okay.
for the print.
Okay. So the characteristics of the seismic signals detected from this event are very similar to the characteristics of the seismic signals detected from the previous declared nuclear tests. So from that, member states will draw their conclusions about whether this similarity in the nature of the signals implies a similarity in the source of the energy that caused them. So it's up to the member states now to determine whether these signals were the result of a nuclear explosion or some other form of explosion.
In case we are talking about a nuclear testing, and if there is any release of radionuclide, how long could it take to catch, to get this sample? Days, weeks?
Yep. So the question is, how long might it take to have a radionuclide detection if indeed this is a nuclear test? The answer, obviously, is it depends. It depends on whether radionuclide or any radionuclides are released from the site of this event. If radionuclides are they released immediately, or is their release delayed? As we saw in 2013, a release presumably occurred up to 55 days after the event itself. If a release occurs, then the radionuclides must propagate downwind. That may take several days. If they pass over one of the radionuclide stations of the International Monitoring System. Then they must be collected. That collection process can take between 12 and 24 hours. Then in some cases there is a pause before a several hour or 12-hour pause before the sample is counted, and the counting might take 6, 12 or more hours. So if you add all of those delays together, the earliest I would think any radionuclide data might be available is several days. The latest might be months.
One last question.
One more question about the possibility of a hydrogen bomb. I mean, in the past there have been tests of hydrogen bombs in the world. How large were the seismic shocks that these tests caused typically?
So again, tests, prior nuclear tests have occurred at all various ranges of sizes. The nature of those tests is, I would have to say, of less importance to a treaty monitoring perspective, regardless of the size of a test. If a violation has occurred, any size nuclear test is a violation. So the role of the CTBT is to ensure that we detect any violation, not necessarily try to ascertain technical intelligence information about the nature of a country's program. So in this regard, all I can say is that any test is a violation. Our system is designed to detect whether a test has occurred, not necessarily the nuclear nature of the test.
So you don't know how big the tests were in the past?
Oh no, precise information has been provided on prior nuclear tests, so they range in all sizes. And I don't think one can put a particular cap or threshold on one type of test versus another.
Okay, we have one more question from AFP.
From AFP. If your stations manage to pick up radionuclei and analyze them, will you be able to tell if this was a hydrogen bomb explosion or a regular fission explosion from
Okay, again, the radionuclide information that we will collect will allow member states to better determine for themselves whether this test was nuclear or non-nuclear. The precise nature of the nuclear test, what category of weapon, what design the weapon had, is not a function that we would be involved in trying to determine.
But technically speaking, from that data, it would be possible to determine
The different types of radionuclides that are released after hydrogen bomb or not hydrogen?
There are, well, again, this is something that's in the realm of nuclear weapons physics. We here at the CTBT are involved in detection of information that allows member states to make their determinations of whether a violation of the treaty occurred. The precise nature of what one can determine from a suite of radionuclide data is something that the member states would then be able to respond to.